Let's go ahead and do this. All right. So basically, again, this is stuff that you have in your file folder, so you can see all this. And again, I'll download this to YouTube here as soon as I get this thing done.
What's change mod?
Change mod? That's an interesting thing. It's stuff. All right. So remember your basic Linux commands, right? These are the basic ones you guys learned in 2.15 and really annoyed the crap out of you in 2.17. Are going to really lead you guys to hatred after this, all right? So rmdir removes a directory, but only if it's empty, right? rmdir minus r removes the whole thing regardless of whether it's empty or not. Because you guys are going to be using a lot of temporary directories during this whole thing, remembering how to remove a directory without having to tear it out piece by piece is really going to make your day tons easier. All right, I mean, it's like seriously make your day tons easier. chmod 777, this is one of the things that I've always seen people do is they forget to make their file read or write, right? They forget to make their script executable. So we'll just sit there and go, oh, I'm not really runnable, so I don't know what to do with it, right? So one of the things you can do to test your script is to make sure that you've got all the permissions right, right? If you're using a directory, you can do a change mod 777 minus R to just recursively change everything in the directory, and you don't have to sweat it, right? And this one, I'm not going to be so much worried about security in terms of directory security and things like that. I'd rather have the script just run, okay? So I'm really easy with that. Whenever I run the script, I'm just going to change it over to 777 and call it good. All right? grep. Everybody remember grep from last year or last term? All right, so ps minus ef grep Apache 2 looks for everything. One of the things you're going to notice is that there's a subset of this called egrep that's going to be used when you're using regular expressions. We covered a little bit of regular expressions in 210. We're going to cover a whole lot more about regular expressions in this class, because regular expressions are a really good way of slicing and dicing data. And you guys are going to have a lot of data to go through.
Can you define what regular expression is?
Regular expression is basically how you look for things like an IP address, or how you look for a social security number, or how you look for a phone number in a data stream. And again, we're going to cover a lot more about regular expressions as we kind of go through this. All right, you're going to learn a lot about regular expressions. You're going to hate regular expressions as much as you guys hated looking at system logs last term. Guaranteed. All right. Find, everybody remember the command find? Find a file or location of files on a hard drive. All right. Really super important command, because sometimes we forget where we leave things off. We forget where we are. So find is really handy for you. Echo. Echo writes data to the screen. It's also known as standard output. The TTY, right? TTY is your standard out. So when you see me use your standard out, that's exactly what I'm talking about. I want to see it up on the screen. All right, so you're going to learn a whole bunch of new language in here as well. All right, so standard in, standard out, standard error. These are all things you're going to encounter in the next week. All right, more. Displays the contents of a file one page at a time. It's really hard for large files like syslog. All right, so I'm really going to recommend that you be in a desktop environment so you can actually go and have screens up while you're doing this, because it's going to make your life tons easier. All right, clears the screen of text and provides a command prompt. Sometimes you just get overwhelmed with the amount of garbage that's on your screen, so just clearing it can go an awful long way to making your day a little bit easier. So clear is a really good one to have. And then chown, change the owner of a file or directory. All right, because if you write the file as root, I can't run it. So you want to make sure the file is written so that we can all use that file at the same time. So whether that's student or something else. All right, RM, remove a file. You guys are going to create a lot of temporary ugly garbage throughout this class. So remembering RM to remove a file is makes your day a lot easier. Move, everybody remember what move is? It allows you to move things around, but leaves your original intact to a certain point, right? It allows you to new place or new name. Change group, change the group. Huh?
If move also allows you to change the name of the file.
Yes.
Or a new name, huh?
Yep, new name. Yep. So change group, change the ownership of a file. All right, that's kind of important, because remember, we all got to be running it at the same time. All right. Make dir, make a directory so you can make your temporary directories. And then you want to change mod 777 so everyone can write to your temporary directory, because if you run this as a service, that service may not have permission to the directory that you're writing to. So when we go in and we start doing things by the clock using cron, you're going to want to make sure your directory is writable, otherwise your job will fail. And that's generally a bad thing. ls, list the files. I've been teaching ls-la because I like the long form. I like to know what the permissions are, who owns it, how long it is, and all the rest of it. So I'm a real big fan of ls-la. All right? And in this class, I'm going to really recommend you just get used to using ls-la, the long form of the output. All right? Cat, it's an alternative showing the data in a file all at once. Some people learned cat, some people learned more. They're interchangeable. So not a big deal. All right? PWD, display the current working directory that you are currently in. Can be painful. Right? Password, change the password of the currently logged in user. Sometimes you may want to do this. You may have to do this in a script. Hint, you may have to change passwords for users in a script. All right? Now, when we're manipulating data output, the things I've seen are people get confused about what all these symbols mean. All right? So there's a lot of symbols used when you're doing programming. If you use the two sideways carets, it's append data to the end of a file. All right? It's append. If you use one, it's overwrite and kill whatever you have in your currently existing file. So if you're busy working on your script and you're doing cool stuff and you wipe it out because you didn't append, you just merely wiped it out and started a new file, make sure you have backups before you run your script. All right? Please, make sure you always have a copy of your script. Never run your script off the original in case you boo-booed. All right? And that is a technical term in programming, as I boo-booed. All right? Pipe characters, you can string commands together. So you can string an ls-la, you can string a more, you can string a write to your password file. So you can string multiple things together to kind of make it a little bit more compact and easier to understand how the logic works. If I do this, and then I do this, then I do this, and if all this worked great, then this is my output. All right? It makes debugging harder because you don't know where it fell apart. You don't know which one of those strings fell apart in the piping character. All right? So you have a choice. You can go for elegant, which is string everything together, or you can go for functional, which is make everything in a linear line down. I'm good with either way. If you're debugging, I really suggest putting them line by line, right? Because it makes it tons easier to debug. Everybody remember what the problem is with Linux debuggers and Windows debuggers, any debugger? The program runs at computer speeds. So when you get line error 122, that means it can be anywhere between lines 17 and 22 when you're debugging a script, because the script will run faster than the computer can throw data back at you. So if you see line error 22, that doesn't necessarily mean it's line 22. It means something between 17 and 22 has gone kind of screwy.
Three lines.
About 5 lines.
Five lines.
Somewhere in that 5 lines that precede where the error code is. Now you do. You have the power.
Yes. He did actually tell us that before.
You forgot. I forgot about that. All right. If you see 2 pipes, this is a logical OR. In that A or B is a loop, a conditional. It either has to be A or B. If A or B happens, then I can move on with my programming. If A or B does not happen, then my program stops. So if Dan's true name is Dan, or Dan's true last name is Morrill, then go do something really cool. All right? But these 2 line slashes can save you a lot of typing. All right? So I believe in shortcuts. Yes, sir?
So you would actually write that into a script, or would you write that while you're debugging the script?
I would actually write that into the script and understand that this is what I'm doing. I'm checking for conditionals of A and B, or A or B being true. Right? So you can just put 2 pipe characters in a script that will evaluate condition A and then evaluate condition B. And if either of condition A or B is true, then it will continue moving on with the script. Right? Now, this one's really handy, and this is a new one for you guys, the and symbol at the end. So when you type in the script name /script space and, it will run that script in the background, which gives you the ability to still use that command terminal that you're using. Right? So if you're on one terminal, run your script in the background, because then you can still type and do other things as you're going on through this, because some of these scripts will take a long time to run that you're going to be writing. All right? So background processes are really cool. It still shows up in your process service, right? So you can still see it running. You'll just see it running with the and sign at the end of it. All right? And. This is a logical and. A and B. If A succeeds, run B. Right? So both A and B have to be true to make it go. So or A or B has to be true, and A and B has to be true. Kind of make sense? Good thing I'm leaving this up and that I'm recording this right now. All right? Sleep. 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 Everybody go to sleep. All right, so sleep. Stop the execution of a script for a certain number of seconds. And this is really cool if you want to screw people up, right? Because everything runs at computer speed. Sometimes you need people to, you need to slow your script down a little bit. So sleep is really good, but it's in seconds, right? So if you sleep 20, then you're sleeping for 20 seconds.
So it's not in milliseconds?
It is not in milliseconds. It is in full-blown seconds. So if you're pushing data up to the user on the screen, right, you want to have that user see the data. So you're going to sleep for a minute or two so they can read what you wrote, right? And then you do clear, and then you let the screen fill up with more data. So you can actually step through your program if you're getting a lot of data back to the user. All right, so sleep is a really good way of slowing down the output so that users can actually interact with your script or read what your script is throwing back up. All right, so sleep is really good. So if you say sleep 20, it means sleep for 20 seconds. Usually, given our modern MTV kind of choppy way that we do things, Battlestar Galactica chops, right? Users are really able to get a gestalt of data in about 5 seconds. Sleep 20 is about right. If you sleep for 60 seconds, if you sleep for a full minute, user starts to get disengaged from your program. If you sleep for 10 minutes, the user's walked away, he's gotten a cup of coffee and all the other things. So if you say sleep 600, you're really telling them to wait 10 minutes before the computer does anything else. So you really want to think of your user while you're doing this as well, right? Think of your user dynamics. Diff. This is one of my favoriteest commands in Linux ever. Diff allows you to compare the contents of two files, right, and see where the changes were made. If you keep your original and you're working off another script that you've been editing, you can see the difference between the original and the one you've been working on. So you can see the changes that were made, and you can back out bad changes. Never work from the original script. Always work off something else, because if your script goes bad, you've at least got a fallback position, and you can see where those changes actually happened. Yes, sir?
So the syntax would be file name, diff, file name?
It would be diff, file name A, file name B. So sdiff. If you have the screen up in the 132 column display, you can actually bring them up side by side, and as you scroll, the screen will scroll with you, and it will highlight those differences for you. So it's really kind of a cool way of looking at it, right? So if you do sdiff file A, file B, as you move around on the screen, those files move around with you, right? So really makes debugging tons easier, and that's really what we're going to be doing in this class, is checking to see where the script I handed you and the changes you make, how they work out, right? So those are two really handy commands to see the differences between files. If you do diff, it's just going to hand you a bunch of data on where these things differ. If you use sdiff, it's actually going to highlight stuff back and forth. There's actually a Windows program called diff that you can download if you want to work in the Windows environment for your Linux scripts. That's absolutely totally cool. That will also do all that highlighting and line numbering and everything else you've got. So if you want to do the Windows program diff, by all means, it's a free download. It doesn't cost anything. I also recommend Notepad+, for writing scripts, because it gives you all the line numbers and everything else. How many people have worked with Notepad++ before? Okay, so you guys know about that program? I do pluses. There you go. There you go. Go with it. Cope. Just learn to cope now. All right. All right. LP. Sometimes you want to print your file out, so LP prints the file to the configured printer. It has to be whatever printer you've set up for this, right? LP stat shows what's in the queue. So if you didn't set your printer up right and you've been dropping things to LP all day long and you're not getting anything else at the printer, do an LP stat so you can see what's actually in queue. And maybe you boo-booed, technical term, made a boo-boo with my setting the printer up. You can go through and fix it. Now, here's some other things. If you have the single, those aren't closed. If you have the single parentheses, thank you. If you have the single parentheses, it runs the enclose command in a subshell. Right? So you can enclose things that you want to run as kind of separately off the main program. If you do a double parentheses, it's an evaluation string. And people forget about that. They'll do doubles or they'll do singles when they really wanted to evaluate something. Right? So it assigns a value to a variable that you'll declare. It also does some cool math in there if you want it to do math. Right? Computers do math really, really, really well. There won't be a whole lot of math in here. Right? So if I hand you a structure like this that does an evaluation, these will be good. Because I don't think anybody wants here to really do things like tangents and cosines. How many people really want to do tangents and cosines? Two. That's all? Darn. All right, we'll give them the math. You guys can carry on smartly. All right? Remembering basic Unix commands, again, we're back to evaluates an enclosed expression. If you're doing a regular expression, which we'll go into on Wednesday, right? If you want to evaluate data, is there an IP address in here? Is there a social security number in here? Is there a phone number in here? Right? You can put your regular expression in this construct of $ double parens that will evaluate that expression and see if it finds it in a file. Your brain just exploded, didn't it? Yeah. Okay, good. All right. Now, test an expression to see if it's true or false is the single brackets. Right? So is there a social security number in here? You test that whole file for the social security number. If it's not in there, then the test comes up false. So you can use a logical OR. Right? So you can do if A, logic B, test for, right? Then A, B equals, and then end it. All right? You guys are going to have so much fun with this. This is like such cool stuff. You can slice and dice data all night long and have a blast with it. You can be used to compare values or strings, right? So if you know you have a phone number and you want to compare it against the phone number in a database, right? Is the telephone number I gave you really my phone number? Let's test it against the school's database, right? Real simple, real quick. It's a good way of looking things up. Yes, sir?
Are we going to have sample data?
Yes, you will have sample data. I have got gigabits of sample data for you guys. Again, this is the third time I've taught this class, so there's a lot of really cool stuff in here already. And then $ parens, command substitution, great when doing logical ORs or ANDs, right? So you can actually substitute commands inside the process. And you're actually, when you do the keystroke logging script, you'll actually be doing a substitution script along with it, because you want to make sure you're grabbing everything they do. So you want to make sure if they do something funky that you can still grab it. So you actually substitute commands out. Does it kind of make sense? Brain hurt yet? Remember, this is just the beginning. Are you guys happy you don't have to write this all from scratch, that it's just going to be debugging scripts?
Yes.
Okay. All right. I can do that. If you guys want to do an extra credit, write something from scratch, I'm like really good with that. So how many people want to do an extra credit? Let's write something from scratch. Oh, that's a majority. I'm good with that. We'll just do it as extra credit, right? So you guys can kind of go through. If you have time to do it, awesome. If you don't, we'll just make it do week 5 and week 10. Extra credit for Linux week 5, extra credit for Windows. Yes, ma'am. No, that's cool. All right, so using math in a script. One of the things when you're doing conditionals, when you want to increment or decrement a number, there's usually the double pluses or the double negatives, right? So if you have a value I equals 1, and you're looping something, waiting for something to happen, right, you can increment by 1. Most programmers do increment by 1. If you're NASA, you de-increment by 1. 5, 4, 3, 2, 1. All right? So kind of interesting on how they do it, all right? Now, from what I'm understanding, I could be dead wrong with this, pluses take up more memory space than a minus, which is kind of interesting. That's one of the reasons why NASA actually went into a count down rather than a count up. because the computers back in the 60s, you know, your watch has more computing power than a computer at NASA in the 60s, right? So you can increment or decrement. I'm easy with however you want to do it. But if you decrement and you start at 0, remember you're working with negative numbers, and that changes your logic a lot. So most people are just going to fall back to incrementing. All right? Everybody remember less than or equal to and greater than or equal to. So you're going to want this when you're looking up how many words are in a document if it's less than or equal to the original. Does it kind of make sense? Everybody happy with math? Math is awesome?
Yep.
All right, everybody give me the cosine of 92.
You said no cosine.
No cosines, huh?
Yeah, I'll figure that one out.
Man, you guys just didn't bring up a calculator? Really? All right. Now, when you turn in a Linux script, and this is how you keep yourself out of trouble for doing plagiarism, okay? So pay really close attention to this one. This is how you keep out of trouble. Yes, sir? Negative 0.626. Awesome. All right. I will expect to see this in the header of every script you will turn in. If it's not in here, that's like massive points off. Right? You need to tell the computer that what shell to use. There's different shells. In this class and with Ubuntu, you're going to be using what's called the Bourne shell. So you have to comment out not bin.sh. You have to have that in there. If you do not have this as a first line in your script will never run. Right? So when you're debugging your script, I may turn in a script to you guys that doesn't have that first line in it. Hint? All right?
So our first
Or-
script's not going to have that in it.
Or it may be bin KSH. All right? Which is a different shell than what Ubuntu uses. All right? So be really aware of what is going on in that first line. Then empty line, comment it out. Then third line, the script. Name of the script, what you name this file. Right? I would prefer, because it would make it really easy for me to grade, that you would say, this is Dan's script for controlling world, period. World domination roles. All right? The author, your name, so I know who wrote it. I've had people turn in scripts without any author attribution, and that kind of kills me. If you did not write it, which is a very real possibility, if you did not write it, you'd say author, the original author's name modified by. So every script you do in here is going to be your name or my name and modified by. Some of the scripts are going to have a long modification string, right? Because they were written by one guy, I got my hands on it, I did something cool with it, then I'm going to turn it over to you guys after I break it. All right? The date you modified it or the date you wrote it. Okay, so we can keep track of when these scripts change, because this is really super important in a code base. If we don't know when that code was written, then we don't know how old it is. All right, we don't know what evaluations it's gone through. Yes, sir.
Do the diff command, will it read the commented out?
Oh yes, the diff command reads every line in the file and matches it exactly. This changed or this changed between the two files. So the diff or the sdiff command will read everything that's in the file looking for changes. All right, including things that are commented out. Then the revision number, right? How many times it's changed. So if it's the first script, it's a 1.1 alpha, right? And these letter codes mean something really specific. If you turn into me an alpha script, I'm assuming you're not done yet. You just want me to go through and evaluate it and see if you're on the right track. If you turn in a beta script and all the rest of it, the only thing I'm grading are production scripts. Right? So each of these letter codes really means something really important to a programmer. So all scripts should have A, B, D, T, or P at the end of the revision statement. So I know if it's alpha, beta, dev, test, or production. The only thing I will grade is a production script. That means it has to be fully debugged.
What is the D for?
Dev. It's in development.
Okay.
And then T is test. And again, I will take a look at scripts and not grade them all the way through. But if you turn in a production script, that's the final copy that I'll grade, right? But I will take a look at any one of your scripts up to that production point. Yes, sir.
Yeah, with the bin shell,
Mm-hmm.
does that mean that you're saying that's where the computer uses shell works? Okay.
When you set up a shell, computers have different kinds of shells depending on when they were made, how they were made, what was popular at the time. right? If you're using Ubuntu, all it really knows about is the regular shell. It doesn't know about corn. It doesn't know about C shell. It doesn't know about a lot of things unless you specifically tell the kernel to look for this kind of script. The coding examples are going to be in regular Bourne shell. If you change them over to corn, if you change them over to regular C shells, those scripts may not translate correctly over to that wrong kind of shell. So this really tells the computer how to run it.
But it's commented out.
It is commented out, but it's still the first line that the script looks for, that the computer looks for, so it knows what shell to do. It actually reads that line.
It still reads it even though it's commented, it looks for the commented out.
Yeah, because it needs to know where to run it. It needs to know what language to run it in, right? If you were going to use something like embedded Java in this, you have to tell it whether it's a JavaScript or a Java applet or a Java something else, right? Same kind of concept applies here. It tells it how far up it has to translate things in the computer to actually function and do what it needs to do. Ubuntu is a little bit unique in that corn is old, right? Corn is what I started off with back in the 80s. Sorry about that. It's an ugly Vi kind of looking thing. It's horrible. The C shell is actually really kind of elegant. It's older than corn, right? C shell is what started off programming. But Ubuntu and the changes that have been made in that, most of your modern Linux will just work within the regular Bourne shell. And that's not special agent Bourne. There's no driving cars, there's no guns, there's no martinis or absinthe at the end of this. Yes, ma'am.
In the off chance, because I think it happened, because Ubuntu, the default shell is the Bourne shell, then if that's not in there, it'll run it if you've written your script in Bourne.
It still won't know how to interpret it correctly, and it may error out.
Okay.
So you really want that to be your first line.
Okay.
So if you do nothing else, that should be the first thing you do, is to make sure that we're running in the right shell.
Okay.
So I may or may not hand you a script that will run in the wrong shell that Ubuntu has no idea what to do with.
Okay.
So the first thing you're going to do is go, is this in the Bourne shell? So when you're debugging it, is it bin sh?
How will we know?
By looking at the first line of the code, does it say number sign?
So you'll have something there for us for everything
Yes.
that you give to us.
Yes,
Oh, okay.
you will not have to solo program in this class.
We won't have to guess which shell it's
You will not have to guess, but I may hand you a script that points to a shell that no longer exists. Hint. Right? So the only thing I'm grading are P. Right? Everything else I'll look at and let you know if we're on the right track or not. All right, control structures. Sometimes you really want your computer to do cool things. Right? And this is called a logic loop. And these get kind of fun. Right? So, if then, if test, then stuff I want the computer to do. And you notice we say FI at the end of it. Right? That kind of tells the computer in bin shell, right, in the Bourne shell, that this is how this works. And they kind of flip these two things around. Right? And you notice everything's delightfully indented. Right? This is a really big convention. It is huge in terms of how programs are read by human beings, right? You start off your control loop, you indent, and we hear weird noises in the classroom. Indent, as hopefully we don't hear weird sonar noises. And then the stuff I want the computer to do. And this makes it really super easy for someone to read, right? This is a human thing. It's not a computer thing. The computer could care less whether it's indented or not. Yes, sir? You may have flashbacks if you hear sonar noises. I can hook you up with counseling if you need. No, actually, no. They didn't let me near the sonar room for some reason on a sub. No, I have no idea why. All right, and then if then else, right? If then else is the other one. If test, then stuff I want the computer to do. So if this comes up true, right? Then I'm going to go do this. If it doesn't come up true, then there's more stuff I want to do because the first thing didn't happen. Right? You're going to use if, then, else a lot. Right? And then the same thing, if, and then phi. All right. And then the for loop. For a equals 1. As long as a equals 1, I want you to do stuff. Right? When a no longer equals 1, I want you to stop doing what you're doing and move on. Right? So as long as a is equal 1, then we're good to go. Anything other than that, we're all doomed. While does something, same thing as for. For changes a little bit, but while a equals 1, as long as this value stays 1, right? Then I want you to do stuff, but then I'm going to tell you that you're done at the end of it. And again, indentations are really huge when it comes to me reading your scripts, so for the love of God, please indent your scripts, okay? You hand me a wall of text, it hurts a lot. Yes. All right. Until A equals 1, until we meet the conditional of A equals 1, I want you to do stuff. So as long as A does not equal 1, the computer is going to go do all sorts of things. Case statements, you're going to use case a lot, because case, yes, sir?
Isn't until essentially the same thing as while? Because you're saying while this is going on, do this. And else, do this, so like a while else?
No.
Wouldn't you do the same
No, there is no while else.
Okay.
There's if else. There's
If else.
then if else, right? And then while says, while this value is true, while A equals 1, I want you to do all this stuff. As soon as A doesn't equal 1, I want you to stop doing whatever I told you to do and move on. Yeah. Until A equals 1, until we meet that conditional, I want you to keep on doing all this stuff. Once A equals 1, I want you to go do something completely different. All right? So then case statements, you're going to use case a lot in one of the scripts. So get real comfortable with case. Right? Case. If the person enters 1, then this is stuff I want you to do. If the user enters anything other than 1, then this is stuff I want the computer to do. And you're going to notice this little control code here, EASC. This is the weird kind of computery way of saying escape.
What?
EASC. That is the escape code in a case statement. All right? So if you're stuck in a loop in your case statement, make sure that your EASC is actually at the end of it. Right? Otherwise, you're going to be stuck in this case statement forever and having to do Control-C to break out of it.
And
That will break the case statement so it can go do other stuff along the way. Or call it good, call it done. So it's not just sitting there waiting for 1 or not 1. Yeah. Now you notice when I wrote this, I used the bang equals, right? That's a not equal. So whenever,
not equal 1?
yeah, so if I wanted to, we can go not equal to copy if then do stuff, all right, if equal to copy, smile, right? So you can use this kind of notation all the way through your scripts if you want, right? You can also do something, you probably have you guys seen the not equal to? All right, so not equal to sign, which is the equal sign with the line through it. So as long as it's not equal to 1, then it will go and run rampant throughout doing whatever it's doing. So you can use a lot of math and logic symbols to replace a lot of the words in a script, right? And at the end of this class, hopefully you guys will wake up going, oh my God, that's what this means, right? But it's kind of interesting because you're going to find me doing this on the screen, all right? You're going to find me writing this kind of stuff out, and I'm going to come at it like I'm a programmer. If I use a symbol you guys do not know or are not familiar with, please point that out, okay? Yes, sir?
So I can't remember exactly how this works.
We're going to go over case in detail. This is just day 1, so I didn't want to throw too much stuff at you. You're looking right. What? You didn't? What? All right, and that's basically it for the slideshow. So does any of this make sense to you guys?
No.
All right.
Yes.
All right.
Now I have to go back to my logic real
All right, now, yeah.
and tell them that I'm actually using the shit that I learned.
All right, so how many people have taken the logic class?
Mr. Fox is really happy.
All right, so see, programming, logic, it's a really sad kind of thing. But it really is. It's a matter of what you want the computer to do and how you want it to do it, right? It's either conditional and or it's not equal to, it's equal to. So there's a lot of commonality between symbolics and what's going on inside of a program, right? And again, you guys won't get a whole lot of math. No Venn diagrams. No Venn diagrams, unless they're like funny Venn diagrams. So, any questions? All right. So we're going to go over this piece by piece, and what's going to end up happening is Monday is going to end up being the day you get your hands on your first script, and the day we go over that script. I'm going to do that on Wednesday with you guys. We're going to go over our first script. It will be due Friday of next week. Not Friday of this week, because again, we still need to kind of ramp up. How many people have got spring break brain damage going? Yeah. Spring break brain damage? Yeah. So we're going to go a little bit easy. Yeah. But no, so what we'll do, we'll go ahead, we'll cover your first script and what you need to do with it on Wednesday. We'll go over it line by line and let you guys have at it and do cool, fun stuff with it. All right? Next on Wednesday. No, this Wednesday you get the script. It's due next Friday. Yeah. All right, any questions?
What's going to be the performance of the first group, the output?
We'll go over it line by line when you guys get it. Because I have to cut this thing down from 10 scripts to 4, I've got to figure out exactly what scripts are the ones I want to hand to you guys.
Is that because we're throwing in
Windows PowerShell, because we're going to be able to translate those Linux administration processes straight over to Windows. There's just going to be a few changes in how that actually works. And when we get to Windows, we'll do the same kind of thing. This is how Windows PowerShell actually works. So week 6, when you guys come back off of your final or your midterm and all the rest of it, we'll do exactly what we're doing today, just basically putting the big reset button on the class, and then here's how it works in Windows. Because the math is a little bit different and the control structures are a little bit different. The logic is universal, but the way you express that logic is a little bit different in Windows PowerShell than it is in Linux. Linux is really based on C and C++, right? Where Windows is really based on C, but with a little bit of DOS, and then you can't just leave good well enough alone. You have to add other really cool, fun things to it that most people are like, yeah, you see that whole tilt of the head and wondering why did they do this, because it was cool. It was cooler than a bow tie. So any questions? Unless you work for Windows. No questions at all. You guys are good. You're happy.
Not really, because I have to pull out my logic book. I hate that I have to do that.
Yeah. No.
How's that working for you now?
Actually, if you know Java, then you're going to do just fine in this course, because the structures are extraordinarily similar to each other. So you could probably get away with using Eclipse and using all the other fun things. The only problem is I had one other student that literally thought in Java when they were programming, and they actually wrote JavaScripts instead of C#. Yeah. So that was kind of interesting, because I mean, it's just how the person thought, and I'm cool with that, but it was really hard to grade. Yeah, because then I had to download the JDK, put it on the box, and it got to be really interesting really, really quickly. So any other questions? You guys good? Makes sense? You guys excited about your first script? No.
Are we pulling these drives, or are we leaving these drives in? These were in when we walked into.
Leave them.
So
No, just leave them. Yep.
Okay.
Just don't change the password on them, because that means because that means other classes are going to use that same drive. So you guys should be fine. Yes, sir.
If we're using to do this either at home, if we load a Linux server, and is that going to work as well as the virtual machine? You said something about the desktop being maybe inferior.
If you want to work on this at home, load up VirtualBox. I'm recommending that you load a desktop along with it, because it will make it easier so you can have multiple windows open at the same time. You can have one that's doing tail on your syslog. You can have one that's running your script, and you can be monitoring what's going on with your computer at the same time.
So we can actually use Ubuntu desktop.
Yeah, use Ubuntu desktop. It's going to work just fine.
Okay.
And I'm okay with that. However, when I grade your script, I will be using Ubuntu Server. So you may want to test your script against Ubuntu Server just in case, because there may be hooks or calls that don't translate between desktop and server. So write it in desktop by all means. Every single programmer at Microsoft writes against stuff. They'll either write against server or they'll write on their desktop, and then they'll move it over to a server for testing and debugging. All right.
I'm dumb. You can't have multiple screens open
In
in server, right?
Ubuntu Server, you can if you load a desktop environment on top of it.
Okay.
Yeah.
And that's the server.
Yes, sir.
With server, you can't have multiple servers open.
Cool. So control.
Open up another terminal, you have to log into that one. So you can have multiple backup servers.
Yeah, no. If you want to flip between terminal screens, that's cool. I'm more when I'm programming, I like to have everything up on one screen. Right? I'm a lazy person. I like to have everything up on one screen so I can see what's going on.
I just moved the tail minus app so you can watch what syslog is logging.
Yeah. Yeah. So again, this is another thing that I do expect to see at the end of my course instructor made us look at syslog all term long. All right. There's a reason why we do these things. So are there any other questions?
How do you review the last your evaluations?
Oh, I haven't seen them yet. I don't know what my instructor evaluations are yet. And I probably won't get them for about another 2 or 3 weeks. Remember that? Okay, so that's it then. We're good.